All right. So, like I said, we are going to start on part of what factorization. So it's actually you can just so that application of vector so that we see how we use our vectors, which is going to extend vector and the theorem by using the looking expressions, so forth. But the basic part that we're talking about here is the factorization, which is taken from our entry. We had the basic factorization of a quadratic expression. If I had to take the quadratic expression of the format ax squared plus bx. These were the expressions that we actually working on. That is a quadratic expression. And we had a concept that if maybe the coefficient of x squared is a 1, the direct that you can simply apply every one as if our brackets and so forth, whereby we are going to have x here, consider what the vectors of
6 and 5.
Fine. So we need to say our vectors will be 3 and what? So we're going to have x plus 3, x plus 2. It's the same type that or same consideration that we are working under our factorization, but it's not like we are going to have most of these expressions. Yes, we can have expression of this nature from our end, which is an advantage to actually have that part of this time. But mostly we shall be having the quadratic expressions whereby we are not having a 1. The coefficient of x squared is not a 1. So just like for example, we're talking about 8a squared plus 28a plus 24. So if we are given to factorize this part, what you can do, remember the order to is always check if there's something common throughout. Then we have to factor out that common term. So in this case, we are referring to any common term between 8, 28, and 24. We put the highest common factor there, which can be a 4. So
4, yeah, we can use
by 4. So
4, yeah.
This is factorization. So we are supposed to factor out a 4. So in this case, we are going to factor out a 4. But the moment you are factoring out a 4, we are simply what? Divide as 8 divided by 4. Right. So
2a
squared 28 and 4 is going to be what? 7. Then 24 and 4, which is going to be what? 6.
7. Yeah. 6.
So that means we have reduced our expression. It was an equation. We have to divide it. For an equation we are given, so 8a squared plus 28 plus 4 is equal to 4. This is our equation. So the moment you are given an equation, you can simply what? You can simply divide by 4. Instead of factoring out, you can simply divide by 4. For an expression like this, when we are given an expression, we factor out the number only, not divide by the number. All right, so that is what we have here. So after this part now, we can apply our normal factorization. So as you can see, this time we are not having 1 as our coefficient of x squared. We are having a number that is not equal to 1. So we need to say, supposed to apply our longer way, multiply
Mm.
the first term to the last
First
term.
term
That's
and then 12.
then what? 12 is when. Then we need two terms that when we add, they must give us one term, which is 7, 8. So the term that
3 and 4. 3.
so we're going to do we have 4a and what? And 3a. So meaning
And
to
3.
say, if we multiply this with 12, if we add this part, get what? Get a 7. So these are
Yes.
the terms that we have to place
Mm.
into our middle term. Yes, we have a squared. Let's observe an a is to substitute two terms. That would be 4a plus a plus what? Then from there, what can we do? We now group by grouping. So we need to say we are going to have 4 into 1. If we put this into 2, what is common? 2a. So we get
3.
So we can vector out a. 2a squared divided to a will remain with a, or a divided to a will remain with 2. Between these two terms, what is common? Plus 3. So
3 plus 3. A plus 2, yeah.
So we have got the common bracket. So vector out the common bracket. Having our 4 outside, our common bracket being a plus 2. So we are going to make a plus 2a plus
2a plus 3, yes.
another bracket. So with these expressions, might give us the typical expression of nature and also application of different terms based of a normal vectorization. We are used to a normal vectorization, like I gave the previous example, as we are used to a vectorization of maybe we just given x squared plus 9x plus 40, which is we can simply vectorize them. But now what they will just less of x squared or less of whatever x that they can give us expression maybe 3 plus 2 squared
2
plus 9 into k plus 2 plus 1. And you are asked to do, and you are asked to do.
Okay, yeah.
So what can we do? How can we do it? So it is the same approach, just like what we had of application or use of X, where you can even introduce X. If you are used to the X, you can simply introduce X as a normal expression, or you can simply vectorize X, but you can simply let X be equal to k plus 2, k plus 2, k plus 2. So meaning to say, where I'm seeing k plus 2, I'm going to substitute what? I'm going to substitute. Meaning to say this whole part is equivalent to x squared, because it's x squared 9x plus what? Plus 4. This is what we are using our vectors. So meaning to say we can now vectorize this part where here we put from x squared is 1, simply need 2 brackets. Simply need 2 brackets when you put x, and we consider what? Vectors of what? 40.
Vectors of 14.
We must add up
Give us 9.
So which vectors are
We're going to make it 5 and 4 minus 5 times 4.
vectors of 40. Vectors of 14. Because we are saying these are vectors of what? Of 42 numbers that you multiply. They give what?
give us 14, 15, 30, 14 is equals to 15,
Consider 2 and what?
27.
Multiply 2 by 7, get a 14. We add 2 and 7, get what?
Okay, yeah, you get 9.
So, say we make our
9. Okay.
So, say we are going to make what? Plus 2 in this case.
X, yeah, plus 7.
But in
So
this case, our question was vectorized expression that was of what? That was not in terms of x. X is something that introduced that certain expression that was there. So meaning to say on our final answer we must have our k expression. So where the x start to take the original part, which is what data. So meaning to say s of x is here, we're going to start with plus 2. But already there's the what? There's the plus 2.
Plus 2
was already added.
Move
on to the second bracket. S of x, we are going to substitute the expression but x what a plus 2. So that was going to be a plus 2, but already there's a what? A plus 7, which was already there. So by simplifying this, you can collect like those numbers that we added together. We add 2 and 2. That was what? 4. Then we can add 2 and 7.
Okay.
Now,
okay. Yeah.
So when we are given factorization, now instead of giving a normal expression like what, now they will give us expression given in terms of certain data, in terms of certain expression, mostly from the quadratic expression that we are used. That is where we'll be working on. So just like for example, you might even ask to factorize 2 into p plus 1 squared plus 7 into p plus 1 minus 1 minus
2p plus 1 squared. Yeah. Plus
so
11.
what simply happened here is that still a normal quadratic expression. What x quadratic is what?
X is equals to, yeah.
So meaning to say, still have our normal quadratic expression, but it is written now in terms of expression, not in terms of term, as we are using when it's just 2x squared term, not in expression like this. So you can introduce x where we are having what plus say that a or x y x is equal to p plus 1. That means in place of p plus 1, we're going to substitute what? We're going to substitute now we can have that 11x minus 6. So in place of where we are seeing p plus 1, we substitute what? So now we can factorize. So from this type, yes, the coefficient of x squared is 1.
1, yeah.
But we can factorize this, multiply the first term to 1. The last term, multiply this 2 x squared and minus 6, what we obtain?
Minus 12 times 1. Minus 12.
Minus what?
12 times
minus 12 x squared.
11.
So meaning to say we need factors of what? Need factors of minus 3 of x.
It's minus.
But these factors, when added together, they must need to
give us 11. Yeah, it's 12. 12 and minus 1.
We open what?
Yeah.
We open negative 1.
Negative 1.
So meaning to say we are talking about 12x and what? Minus x.
Negative. Yeah.
Right. So that is what you're going to have. So it's simply substitute to our expression. So this now 2x squared. The middle term is the one that we are replacing with what? With these two terms. So we're going to substitute 12x minus x
11.
minus 6.
This means yes.
So minus 6 is same as what? Same as minus 1.
Yeah.
So now we can factorize by
factorize completely. It's
for
equals
the
to
first two terms.
x.
We're going to
It's
factor out
2x.
what? X plus
2x
what?
plus 6. This
All right.
is the second term.
Last two terms, what is common?
Yeah, it's negative 1. Negative 1.
So that means positive x.
Let's combine this x plus x. Okay, so here's 2x.
Now we can factor out what? The common bracket means what? X plus 6. Or you can even start with 2x minus 1 is fine. Just factor out the common bracket of x plus 6. You remain with what? You remain with 2x minus 1 in another bracket. So we have to be very careful on our answer because mostly very easy for someone to underline as the final answer, but that would be wrong because we are saying in order for you to be done, say a done factorization, we must obtain the expression that it was so meaning to say our final answer consists of not x. X is something that we have introduced into our equation, it's not part of our answer. We have to get back to our x. So in place of p plus 1, we introduce x. Now in place of x, we're going to bring back our
p plus 1 here.
So meaning to say this is going to be equivalent to in place of x, substitute p plus 1, but there is what? There is a plus x which is already there. Substitute x with here, p plus 1, but there's a plus x which is already there. Add it there.
Yeah.
And here be careful, it's 2x. 2x means 2 times x. So we are going to have 2 times p plus 1. We have to open a bracket so that 2 is going to multiply everything in this bracket. So this is x. Our x being p plus 1. But there's a what here? Minus 1. Whatever that you're going to get here, you must subtract 1. You must subtract 1. So what are you going to have at the end? Here we can collect like terms. We've got 1 and 6. So if you get 1 and 6, you have 7. And here we have to expand bracket space by 2. We're going to obtain 2p. 2 times 1 here is going to be 2. But we put a minus 1. So 1. So at the end, we're going to have what? We're going to gain 2p. 2 minus 1 is 3 plus 1 minus 1 plus 1.
Yeah. Right.
So that we have our final answer now in terms of p, because we had p. So our answer must consist what of p, not x. That is the major part that we just need to understand to say that instead of having normal expression like what we use to have, they will just try to interchange this expression another way like having another expression, but being the same thing. That's
yeah.
So that is what we're supposed to expect. So just need to work with more questions paper to see how do they actually ask these typical questions. How to attempt. Like I said, most of the factorization from our into most of it, the part of it, the question and proof with more questions and so advice into all right, so we have another part which is taken from our N1. N2, we do not have vector and remainder theorem taken from N1 that was where the vector and remainder theorem was introduced. So this part also going to follow us in our N3. So what vector So another part. Still we are talking about what? Vectors.
Vectors, yeah.
But sometimes it might not vector because there might be a remainder. Once you have a remainder, that means that part or that particular expression that you talk about, not a vector. If we are referring to a vector of 6 or vectors of 6, these are numbers that are exactly which we divide 6 divided by that number and exact term. Like for example, 6 divided by 2, that's 2, we're going to obtain a 3, which is an exact term. But the moment we divide the 6 by a number which is 5, it's no longer a vector because the moment you divide, we're going to obtain 1 and a remains. So this is not a vector, but it is a vector. So as now we're talking about expression, not numbers. We are used to these numbers. We can list vectors for any number that, but we need to know this in application. What expression we are dealing with expression? What is it that actually refers to as what as vector? We are given vector. What is expression? Given for an example, we've got an expression of f of x, which is maybe a cube expression of ax cubed plus x squared plus 3x. Just an example of the expression. Then we are saying there is a vector of this expression. Maybe for an example, we are saying x plus a vector. All right. So if x plus a is a vector of this expression of f of x, what does it mean in say? All right. It follows that if we equate this x plus a, we are going to take, we have got x plus a. I want you to take note of this sign for a. X plus a, that is our vector. So it follows that, or therefore f of minus a, this is supposed to be if x plus a is an expression. That expression of x plus a is a vector. Therefore, f of minus a should give us. What are we simply saying? We are simply saying if we have to get x plus a, meaning to say that a to that side is going to be a negative. So negative. The value of x, the value of x that you are having here, when you have equated expressed effect that is the one that we are saying if you substitute, because f of minus a is in place of x you are substituting one minus a. Just like f of 1, it means f of 1, I'm substituting 1 in place of x. If I say 0 in place of x, I substitute 1, substitute 0. So we are saying if it is that we are having a vector, the f of a negative of this number, it was a positive, but here we are using a negative. It must give us, like for an example, let's say, let's just say x plus 2 is a vector. X plus 2 is a vector of f of x. What does it mean? We are saying this one is a vector of what? Of f of x. What does it mean? Vector of f of x. What does it mean in actual sense? If x plus 2 is a vector, just like this part, we said x plus 8 is a vector. Therefore, what does it mean at the end? Therefore, therefore, we're going to have what? This part, we are saying x plus a is a vector of f of x. Therefore, f of minus a equals a. So here we are saying if x plus 2 is a, therefore our final say supposed to be f of what? F of minus 2. Positive.
Negative 2. Negative
so
2.
Say it is going to be what? F of minus 2 must be equal to 2.
Yeah, it's going to say, yeah.
So what is important? You can simply equate x plus 2 to so that you know the value that you're going to use. The value of x that you are using, which is by equating x, you're going to obtain minus 2. Meaning to say the value of x here is the 1, you're saying it is equal to, so you substitute it into an expression.
Okay, yeah.
So meaning to say, if you are to test for a vector, you are testing that this is a vector, x plus 8 is a vector, x plus 2 is a vector, x minus 5 is a vector. By just testing, it means we have to substitute f of certain value. To get a 0, it means the vector. But if you do not get a 0, it's not a
0. It's wrong. It's not yet.
That is the most important part.
Yeah, you have to give it a 0.
So meaning to say, if we were given a consideration that x minus 3 is the vector, which part are we supposed to use so that it gives us the 0? So therefore, it is going to be f of what? It is going to give us
f of plus 3. F of 3 is equals to 0.
So we need to say f of what? 3. Because here it was a negative.
3.
Change
Negative. We change it. Yeah.
We are simply multiplying by negative. Negative is a positive. Or simply x minus 3 is equal to 0. So x is equal to 1. X is equal to 3. So meaning to say the value of x, which is equal to 3, when substituted back into our f of x, must truly, it is what? But if not, if it's not that it's a vector, then it's something else. So that is the major part that we are supposed to work with. So like I said, this can be used to test for a vector. If truly a certain expression that you are given the vector, this can be used to test the test. Before we talk about factorizing the cubic expression, you just need to test for the given vectors. Are they exactly the vectors of those expressions or they are not? So this is how we can get such questions like prove that. Even just a question, prove that x plus 3 is a vector x cubed plus 5x squared minus 8 got given a certain expression to prove that a certain expression. How can we prove? We are simply going back to this part to say if truly x plus a is a factor of f of x, therefore f of minus a must give us a zero. It can give us, it means truly it's what? The factor. So if we are saying x plus 3 is a factor, it means which value are we supposed to use? F of what? It's going to be f of what?
F negative 3. Yeah.
F of what? Of negative.
Negative.
So thus we are supposed to prove, if we can prove this, that f of minus 3 is, it means therefore truly x plus 3 is the what? X plus 3 is negative. So our question has to prove. So meaning to say we are going to prove that f of minus 3 should give us. If it is not given, it's not a vector. So let us find f of what? F of minus 3. So f of minus 3 simply means less of x. We are substituting what? We are substituting
Negative
3, the exponent of 3 plus 5 into negative 3 exponent of 2 minus 18. So
18.
that is substitute from our calculator, value of what? Value of x being what? The value of x being negative 3. So that you can see if we have what? We are going to obtain so
0, yeah.
So we are going to have negative 3 cubed 5 that's
18
squared 8. So give us what?
They must give us 0.
Meaning what?
Give us 0.
So if obtaining a 0, what does it mean?
So it means the factor.
So therefore, that this is there. Therefore, x plus 3 the vector of So this is the major part that we see from our vectors. So it might be given any type of expression. Let's just have an type of proof. Again, we can just ask proof, but only that we just need to be careful of some of the expressions like this one, where we given to prove that x minus 1. So prove that 2x minus 1 is the factor.
2x minus 1
So
is
vector of 2x cubed plus 3x squared.
2 squared plus 10.
So we are asked to prove that 2x minus 1 the what? As we found, we simply need to find, so it's gonna be f of what? F equation, which must be
That you can take this. So it will be a positive 1.
positive 1.
Positive 1.
Take note, on our part we say if we are given x plus We need to say here
X.
coefficient x must be 1, not any
Must
other
be 1
number besides what?
number,
Besides 1.
like 2x.
So
All right.
here we put 2x. So the best for us to equate to take it x minus 1 equal to
1 equals to say all around. Then you can take 2x equals to 1.
So the way that we can calculate this one. So meaning to say by solving our equation, develop x is equal to 1. 5 by 2 by 2 equals 1. So meaning to say we are here our x we have equate x minus 1 2. So meaning to say f of 1 f of half, which is supposed to be 1. So this is what we fully f of half less x plus half equal to 3 plus 3 we can have get exponent of 2 plus 10 by half by every part where there is what within x substitute. All right, so if you have to check here, what are we going to have? That's 2 into exponent 3 3 plus 3 into exponent of 2 plus exponent of 2 plus 10 by half 10 by minus 6. All right, at the end, so meaning to say, through the f of half giving us drops, therefore, which means x minus 1 or that. So this is how we are going to attempt this. You are asked who or what for the equate that vectors by simply equating that vector to 0. It means that we have developed x to substitute. So we are going to substitute that value of x that we get there. So sometimes just for interest sake, like let me get we might be given to prove that again. X part x minus 4. All right.
Yeah.
So if you are given this, here we step we can simply use the factor concept. Because just like a normal number, like let's say with 12, there are so many factors. We're talking about 2, we're talking about even 1, we're talking about 3, we're talking about 4, we're talking about 6, we're talking about 12. So considering the factors, so it can happen that if I multiply these two, I might not obtain vector, or I might obtain this big vector. So meaning to say we are talking about the quadratic expression, but it's not like exactly we are going to have these two terms given as vector of this number. Yes, we can have a consideration of such particular terms like here, having 2 and 3 or having 3 and 4. It can happen like that. Having 2 and 6 can happen like that. That you can multiply the 2 and so that exact effect of what of your. So when you are taking this time, best way for you to get under a longer way vision. I'll talk about that one later on. But for us, here we just need to test, is this truly a vector? Is this truly a vector of what given expression that we have? So when you say from the first one, if we are to consider x plus 3 being equal to 0, it means our x is that was 3. So meaning to say f of minus 3 must give us. So we are going to test wherever is x, substitute minus 3. Wherever there is x, substitute minus 3. Wherever there is x, substitute minus 3. And so we must get the same thing for x minus 4. We need to test also if we are to say x minus 4 is equal. We need to say the value of x there is a 4. So if we are saying f of 4 equal to, it means in place of x, we are going to have 4 exponent of 3 and 7 times 4 exponent of 2, 6 times 4 plus 36, which is supposed to give us. But we can actually have in another way, which we shall talk about later on about this. But most important part that I need us to understand is how to find from the vector that you are given by equating the vector to 0 and substituting to the point expression. See if fully that gives you so there are actually so many ways that you can use to prove that a particular term is a vector, but this is the easiest part of just equating that part that you are saying is a vector. So by equating to 0, that means you are now having value of x. Value of x that you are having, if you substitute back that value of x into your normal expression, you must change. If not obtaining a 0, it means it's not a vector. It's not a vector. If you are not obtaining a 0 from that particular term, particular expression, so that is not what that is not a vector. So this leads us to the remainder theorem. So we can just talk about the remainder theorem, and now we talk about what's the part of it. We have factorization part of cubic expressions, so that we do not confuse factorization that we did, but it's going to be a continuation of this part. I want you to revise along vector part as much as you can, because that is where we are going to continue from on our factorization of what of the cubic expression. So what about the remainder now? How do you consider that this remainder? If we are given, if before we say if x plus a is a vector of f of x, meaning to say this is exactly divisible by that part, it follows that x f of right, let's just write it 1. So follows that f of minus a must be equal to 1, must be equal to 0. At this time now, for a remainder, if we are saying we divided by x plus a, no longer a vector, we are just divided by that expression. If this expression is being divided into our f of x, it follows that the same thing that we are going to have f of minus a equal to, so just as usual, to equate that part, the f of minus a is not going to give us, it's not going to give us, it is going to give us certain value, which is not what, which is not. That value that you are obtaining when you substitute the f of minus a is your remaining. So we are simply saying f of minus a this time equal to the remainder. That's simply our remainder theorem. All right, all right.
All right, so like I was saying, this is a revision on what we have already discussed or talked about before. If we are to check the first question that we are given here, we are told that what must be added to this part?
But yes.
So that 2x minus what? Minus 3
And
is a factor of this expression. What must be added?
Added.
So meaning to say there is a term that is in short here. There is a term that is in short. We need to add another term there. We need to add another term. And by just looking here, this is what? It's a cubic expression. The highest exponent is what? It's
x cubed.
3. So meaning to say our expression was supposed to be written as ax square ax cubed plus bx squared plus cx plus what? Plus d.
Plus 1 d, yeah.
This is what our expression was supposed to be like. But if we are to check now on this expression, we'll see that we have got this x cubed, which is this part of ax cubed. But we do not have the part of x squared here. So meaning to say the part that is missing is this one. This is the part that is missing, this one. Because we have got the part of x here. We've got x, which is our x here, cx. One, it's a constant, which is same as d. D is a constant. So meaning to say this part is there, this part is there. But the part of x squared, the part that is having x squared is the one that is missing there. So as we need this part here, so we can have it as an expression now to say, since we have this part here of 2x cubed, this is our ax cubed. So we are going to have 2x cubed, but we do not have what? This part of bx squared. So we are going to write it as what? Plus bx squared.
X squared, yes.
The part of cx, where there is x here, we have this part that is our minus x.
X.
D, a constant, we have our constant here, which is what? Which is 1.
Yes, 1.
So that is how our expression was supposed to be like. So meaning to say the part that is supposed to be added is this part. This is the one that is supposed to be part of our cubic expression. But we have to find the value of b now. So where are we going to have the value of it? They are saying if this is what? A factor. So what do we know about a factor? We said if we are given a factor, if 2x minus 3 is a factor, we know that we are supposed to find what? The value of x. We have to find x by equating this to 0.
To 0, yes.
So if we equate this to 0, we are going to have 2x minus 3 equal to 0. So 2x will be equal to what? 2x will be equal to 3. Divide by 2 both sides, by 2 both sides. So x is going to be what? 3 over 2. So this is the value of x, which gives us what? Which gave us as with that if you substitute, you're gonna get a 0. So if it is a factor now, what are we going to do with this value of x if it is a factor? it means f of what? F of this value of x here, which is f of what? F of 3 over 2 must be what? Must be equal to 0. If
is equal
2x minus 1 is a what? Is a factor. Are we together on this part?
Yeah, it must be equal to.
If 2x minus 3 is a factor, then it means that f of is supposed to be equal to 0. But I said if it is a condition of a remainder theorem, f of 3 over 2 is supposed to be equal to what? To the remainder. All right. Now this is what we are saying. F of what? 3 over 2 is equal to 0. So this is where we have our f of x here. This is our f of x. So what does it mean? We are going back wherever there is what? Wherever there is x, we are going to substitute what? 3 over 2. Wherever there is x. So let us have this now. All right. So our statement is that f of 3 over 2 is supposed to be equal to 0. F of 3 over 2 here. All right. Is supposed to be equal to 0. So let us substitute. Where there is x, we put 3 over 2. So it's going to be 2 times
3 over 2
cubed. Here, where there is x, we substitute 3 over 2 again. So it's going to be plus 3 over 2 squared times what? Times b.
Yeah.
Because there is a b here.
There's a b.
All right. Then we move on. Minus x. So it's minus. Where there is x, we put what? 3 over 2.
3 over 2.
Plus what?
Plus 1.
Plus 1.
Plus 1.
This must be equal to what? It must be equal to 0. So it's an equation now that we have formulated. So in this case, by formulating an equation, you are supposed now to solve for the unknown. And the unknown value here is b. So you're supposed to solve for what? Solve for b. All right, so let us save our calculator so that we can simplify what we can simplify in this case. All right, so this is what we're gonna have. All right, so you can see the calculator now. All right, so the first thing, we're gonna simplify this part here, and this part, and this part, where there's no b, because yet there is a b here. So we're going to ignore. All right, so let us combine 2 into 3 over 2 to the exponent of what? To the exponent of 3. We move on to this part of what? Minus 3 over 2. So you're going to have minus 3 over 2. Then we move on to plus 1. All right, so we are simplifying the numbers alone. Simplify the numbers aside. So simplifying the numbers, what are we getting? 25 over 4. We are going to obtain 25 over 4. So what is remaining now? We are going to simplify this part now where there is a b, this one. So this is the only part that we are going to simplify, which is what? 3 over 2 squared. So we're going to have 3 over 2 in brackets like this squared, which is going to be what? 9 over 4.
Yeah.
So this will be plus 9 over 4, but it's plus 9 over 4 what? Plus 9 over 4 b. Remember, there is a b here.
Yeah.
So this is supposed to be equal to what? Supposed to be equal to 0. All right, now let us solve for what? Let us solve for b. We can transpose this to the other hand so that it becomes a negative. So we are going to remain with 9 over 4 b, which is equal to this side, it will be a negative. So it's going to be negative 25 over
4.
Negative 25 over 4. All right, so what can we do to find b? We can simply divide. Yes, we can cross multiply, which is fine. I'm not saying it's wrong, but here you can simply divide by 9 over 4 both sides because we do not want this. So we are going to divide by 9 over 4 this side. We divide by 9 over 4 this side. So this can cancel. We remain with what? We remain with we remain with the b. All right, so that is what you're gonna have. So if we are to divide this, what are you going to have at the end? Negative 25 over 4. So you're gonna have negative 25 over 4 like this, divided to 9 over 4 in a bracket. So we've got 9 over 4 like this. So this is going to give us negative 25 over 9. All right. So meaning to say the part that is going to be added in this whole expression that we had, remember, we said our expression was supposed to be like this. This is what we're supposed to work with. We're supposed to work with what? We're supposed to work with this expression. But now we found that the whole expression that we had before was this one, which is 2x cubed minus x plus 1. So I said, what must be added to this part? The part that must be added is this one for what? Bx squared, this one. We are supposed to add this one, bx squared. So we found the value of b, which is what? Negative 25 over 9. So therefore, negative 25 over 4x squared, because it was bx squared, the part of bx squared. So we've got our b and x squared. So therefore, this is the part that must be added.
All right. Okay.
Are we seeing? So the moment we add this part here, or the moment we put this part on our expression, that part or this 2x minus 3, it becomes a factor.
Okay.
Are we seeing how they are trying to ask this question?
Yeah.
Okay. So it would be just a play around. They want you to play around with your information. They know that if they just give you a direct question, prove that it's a factor. People are now used to those questions. So now they just try to confuse you by these statements. So we are supposed to try by all means to analyze your question. How am I going to answer this question? That's the first thing. All right. What about this one? We are given here that, what are we given here? Determine the value of P. If this f of x gives a remainder of what? A remainder of 6.
6, yeah.
Well, when it divided by what? When it divided by 2x plus 1. All right. So our question is, if we are to divide by 2x plus 1, if we are to divide by 2x plus 1, what is the first thing? It is to find whether it's a factor. This one, whether it's a factor or not, the part that is dividing, you have to find the value of x there. Find x. That's the first thing. Whether they are going to say it's a factor or not, that part that is dividing is divided by, just like this part that we had here. Let us get back to our previous question so that we do not confuse each other here. Our previous question, we're given that this is being divided by what? What must be so that 2x minus 1 is which means the moment they are saying 2x minus 3, this one, it's a factor. That is the one that was being divided. So this was divided by this. So that is why we have to equate this to 0. Calculate the value of x. We have to find the value of x.
Yes.
But we are saying if it is a factor now, f of that x that we got must be equal to 0, which is opposed now when it is what? When it is a remainder. F of the value of x must be equal to the remainder now. Those are the questions that they will give you. They'll be just playing around. Factor, remainder, just like that. So that is where you're supposed to play around. So let us see here. We are saying the first thing is to find what? To find x by equating these to 0. The part that is dividing, we are going to equate to 0. So what would be our x there? 2x is going to be equal to minus 1, divide by 2 both sides. So x is going to be equal to what? Minus 1 over 2.
Minus 1 over 2.
All right. So we have the value of x now.
X now.
What are you going to do with the value of x? Is what is important. Knowing this value of x is something else. What are you going to do with x?
Into its value of x, yeah.
So we are saying now, because it's a remainder, so f of this must be equal to remainder. So f of minus half must be equal to the remainder this time.
Remainder, yeah. It's equal to 6.
And our remainder is 6. So f of minus half, it's no longer equal to 0. It's equal to a certain value, which is a remainder. And this statement here alone, what does it mean? It means where there is x, I'm going to substitute minus half and equate my answer to 6. So that is what we're going to have. Remember, our f of x, we have it here. Our f of x is given as what? As 2x squared plus px minus 5. Is that so? All right, so let us have this statement, because we are saying f of minus half must be equal to the remainder. So let us substitute now. Minus half in place of what? In place of x. So we are going to have 2 into minus half to the exponent of what? Exponent of 2. Plus px. So this px is simply times minus half x. So you can write minus half times times p, or you can write p times minus half like this. It's one and the same thing. It just means one and the same thing. So you can just start with minus half as long this is your x. All right. Then we have got what? Minus 5. Can we substitute something on minus? There's nothing there. So
yeah,
after substituting minus half in place of x, our answer is supposed to be what? Our answer is supposed to be equal to 6.
Equal to 6.
So we have formed an equation. And whenever you form an equation, you have to solve for the unknown value. And the unknown value is what? Is p. So we are going to solve for p, which is our unknown value. So are we seeing the idea there? The difference between a vector and a remainder. So now we can substitute, we can simplify this part here where there is no p, here there is no p, here there is no p. So let me share the calculator. All right, so this is it here. All right, so let us substitute our values here. All right, I want to take this one at least here. All right, so let us substitute our values. Like I said, 2 into what? Minus half squared. So it's gonna be minus half to the exponent of 2. Then minus what? Minus 5. So we are getting what there? Negative 9 over 2. All right, so negative 9 over 2. Then here plus and minus, here we don't need a calculator. Plus and minus gives us what? A minus. So it's gonna be minus half p is equal to what? Is equal to 6.
6, yeah.
All right, so what can we do from this stage? We can transpose negative 9 over 2 to the other end so that it can be a positive. So you're gonna remain with minus half p is equal to minus 9 over 2 to this side becomes a positive. So it's gonna be 6 plus what? 6 plus 9 over 2. Is that so? So
yeah,
it was a negative, so there is gonna be a positive. So we can add 6 plus 9 over 2. So we add 6 plus 9 over 2, what do we get? 21 over 2. So we're going to have 21 over 2 here. So as we can see, just like the previous part, we're going to divide by negative half, divide by negative half both sides. So meaning to say our p is going to be 21 over 2 divided by what? Divided by negative half, which is here. Already we've got 21 over 2, so we're just going to divide by what? By negative half. So by negative 1 over 2, like this. That will be negative 21. So meaning to say, our P is equal to negative what? Negative 21. So this is the value of P that we can substitute into our cubic expression. And if we divide by this factor that we are given, which is 2x plus 1, we must get a remainder of what? We must get a remainder of 6. Are we together here?
Yeah.
So as you can see, the remainder thing, the remainder part, f of x, the f of x that you got when you equated that part that was divided into 0 is the one that is equal to the remainder, which is opposed when it is a factor. F of that value of x must be equal to what? Must be equal to 0 when it is a factor. All right, so let us check another type of a question. So instead of them asking us, remember I talked about this part of factorization, instead of them giving us to say, prove that it's a factor or find another factor or this, and they can ask us like this. The first part is, prove that is the first one. Prove that 2x plus 1 is a factor of this function. Prove that it's a factor. That's the first question. After proving, hence factorize completely. We talked about this part of factorizing completely. So we have got 2 questions there. To prove that it's a factor of this function, and after proving that it's a factor, we are supposed to factorize. So the first part of a factor is to equate this to 0, isn't it? The part that is dividing 2x plus 1. So 2x plus 1 equated to 0. So we can find x there. So 2x is equal to minus 1 divided by 2 by 2. X is going to be equal to minus half. So like I was saying previously, that what are you going to do with this value of x is what is important. Finding this value does not matter. You can find this value, but if you don't know what to use this value for, then it's going to be wrong. So they are saying it's a what here? It's a factor. So the moment they say it's a factor, it means f of this must be equal to what? F of minus half must be equal to what? It must be equal to what?
It's equal to 0.
Exactly. It must be equal to 0. If fully it's a factor, then it must be equal to 0. So when they are saying prove, this is what you're supposed to prove. Prove this. So if you can prove that f of minus half is equal to 0, then it's a factor. Therefore, 2x plus. So let us prove that. So it means where there is x, we're going to substitute what? We're going to substitute minus a half. So f of minus half is equal to, let us substitute where there is x, it's going to be 8 into minus half to the exponent of 3 plus
exponent 3 plus 4
into our x, which is being minus half to the exponent of what? To the exponent of 2. Minus 2 into x, our x being what? Our x being minus half. Minus what? Minus 1. Are we together on this one?
Yes.
So this is our f of minus half. So let us use our calculator now and see if we are going to obtain what? If we are going to obtain a 0. All right, so that's it. 8 into minus half to the exponent of 3. All right. Plus 4 into minus half. All right, minus half to the exponent of what? 2. Minus 2 into minus half. All right, sorry, minus 2 into minus half like this. Minus what? Minus 1. What are we going to have?
0.
We are obtaining a 0. By obtaining a 0 like this, what does it do? This is what we proved.
Proved, yeah.
So we got that it's actually a 0. So it means, therefore, this part here, it's a factor. So therefore, we're going to conclude now to say that is truly a vector. So therefore, 2x plus 1 is a 2x plus 1 is a vector of f of x, which is this, our f of x here.
Yeah.
I don't know if we are together.
Yeah, we are together.
So that is what you need. You need revision of question papers. And now they are saying, hence the continuation from whatever that was already proved that it's a vector. So they are now saying factorize completely. Remember, I talked about the factorization where we said we're going to work with what? Sorry, what did I do? All right, sorry for that. Let me go back here. Are we seeing the screen now?
Yeah.
All right. So it means that if we are to factorize, which part are you going to use? The long. We're going to work with the long division there, exactly. So we are going to apply our long division. All right. So we are dividing 2x minus 1 into this expression, 2x plus 1, sorry, into this. So we're going to have our
also
long.
here there's no need to look for a factors of 1 or we can just use, because that one is a factor, ne?
Exactly, this one is a factor.
Because we already proved it's a factor, ne?
Exactly, we already proved that it's a factor. So
yeah, there's no need to look for factors for a 1 for what we can use that factor.
Exactly. That is the idea there. We are no longer going there, because if it was like this, like this, what you are saying, if it was just factorize this, then that's where now you start to check for the factors, because we are just given an expression. But here, the moment they are saying hence, it's a continuation from what was already you proved that
it's a factor, yeah.
Exactly, you proved that it's a factor.
Yeah.
So once it's a factor, then we can divide by it direct.
Yeah, we use the long division. All right.
Exactly. So here we're gonna have 8x cubed plus 4x squared and so forth. So here 8x cubed plus 4x squared plus what? Minus 2x minus 1.
Minus 1, yeah.
All right, so now we can divide. So we are going to use the long division to find the other factors. And we said if we are having a cubic expression like this, and we are dividing by a linear expression, we are supposed to obtain what? We are supposed to obtain a quadratic expression on top. That is what you're supposed to. So if we divide there and we do not get a quadratic expression, it shows us that our calculations, they are wrong. All right.
Okay.
So let us divide. How do we divide? Always the first term versus what?
The first term on the side.
The first term, exactly. So if we divide there, 8x cubed divided by 2x cubed, what do we get?
You're getting 4x squared.
We're gonna get what? 4x squared. Exactly.
4x squared.
Exactly. So you're gonna have 4x squared, and then we multiply, take everything here. So it's 4x squared times 2, which will be what?
It should be 8x squared, 8x cubed.
Cubed, exactly. Then 4x squared times 1 is gonna be,
it will be 4x plus
4x squared.
4x squared, yeah, 4x squared.
Because there's a 1 here.
The 1,
all right.
Yeah.
Then after multiplying, what do? We subtract. Whatever that we got, we're gonna subtract. All right. So 8x cubed minus 8x cubed, this one and this one, that's a 0. And
yeah.
All right. 4x squared minus 4x squared
minus 4x. This will give us 0.
A 0 again. All right. So meaning to say here, there's nothing that we got.
There's nothing you can get. Then so we drop it.
We are going to drop this one. All right. So you're gonna drop this minus 2x. We also drop the what? The minus 1. All right. So let us divide again. Always when dividing, our division is supposed to be what? First term versus first term. First term versus first term, always. So if we divide minus 2x this one and 2x, what do we get?
We're going to get -1.
-1.
Negative.
Or
Yeah.
so here we've got -1.
Yeah.
So now -1 multiplies everything here. So we're gonna multiply everything by -1. So it's -1 times 2x.
3x.
It will be -2x. Is that so? -1 times 2x, because it's a positive here. This one is a negative. All right. Then -1 times +1, what do we get? -1 times +1, we get -1.
It's -1. -1.
So from there we're gonna subtract. As we can see, this thing here that we see, this whole expression and this whole expression, they're actually the same.
The same, yeah.
So meaning to say you're gonna get what?
If you subtract it, you're gonna get 4x, right? 4x.
Oh, is that so? No, let's subtract here. Because it's gonna be minus 2x minus 2x like this.
Oh, yeah.
So it's gonna be minus. So it will be a minus 2x plus 2x, which is a 0. The same thing on -1 is gonna be -1 minus minus. So it will be minus 1 like this. So at the end, this one is a plus, which is gonna give us a 0.
0. All right.
Are we together? So our question was for us to factorize. Take note here. The question is hence factorize. So I said, if you are dealing with this part, it means these two combined together, the part that was dividing and what we got here, they give us what? They give us f of x. They now exactly, they now represent your f of x, the product of these two. So it means that if I am to multiply this, I'm going to say f of x is equal to what? The product of these two. What was dividing and the answer. Just like 8 divided by 2, it's what? It's 4.
It's 4.
So it means if I multiply 4 and 2, I must get what? I must get 8. 2 times 4 is equal to 8. We are dividing by 2, we get 4. So these two must give us 8. So this is what we are having here. So it means our f of x is going to be equal to what was dividing? We were dividing by 2x plus 1. And what are we having at the end? We got, after dividing, we got 4x squared minus 1. But our question is factorize completely, not just factorize to say you leave at a certain stage. No, it must be complete. So here it's not completely. Why? Because this is a quadratic expression, and this quadratic expression has to be factorized. We've got a quadratic expression here. So we must factorize again because we are having a quadratic expression. So where now, that is where now I was looking, those quadratic expressions, you have to tell what type of expression is this and how do you factorize this? What type of an expression is this?
This one is big.
This one is a difference of 2 squares, and
different of squares, different of 2 squares.
Because here it's a perfect square. This one is a perfect square. This one is a perfect square. Because we can write this as 2 squared x squared minus 1 squared. So meaning to say this part here being raised to the power of 2 and this part here being raised to the power of 2 is the one that is important. So we're gonna have 2 brackets here. F of x is equal to this part first, the one that we already have, this one, 2x plus 1 into the 2 brackets from what? Our difference of 2 squares here. So we have got this being raised to the power of 2, which is what? Which is 2x minus 1. Remember, one is gonna subtract, another one is gonna add.
1, okay.
So that is our difference of 2 squares. Remember, a squared minus b squared is equal to what? A minus b into a plus b. So that is our a and this is our b. All right, so that is it. We are done factorizing. But again here,
A plus B, yeah.
Exactly. So even here you can maybe just writing to say these two expressions are the same. So it's like 2 times 2 is same as what? 2 squared.
Squared.
So meaning to say if I'm multiplying the same brackets, I can write it as a squared, but already we are done factorizing. So you can write this as 2x plus 1 squared because there's another bracket of what? There is another bracket of 2x plus 1. So it will be squared here times what? Times this one.
2x
Times 2x minus 1. We are done. So we have factorized this. But even here, you're going to get full marks.
Marks, okay.
You have your full marks. You are done factorizing as long we have all the brackets. And sometimes you can actually factorize and get a quadratic expression, which cannot be factorized. This one. You can get something that cannot be factorized. It's normal. You have to write it like that. Maybe our final answer was going to be maybe it's 2x plus 1 like this into 4x squared plus 1. 4x squared plus 1 cannot be factorized. You leave your answer there, you're done. But if
you're done. Okay.
that part can be factorized, then factorize it. Are we together on this part?
Yeah.
Exactly. So these are the typical questions that you're supposed to work with in your revisions. Let's see if we're gonna have another part that is different. This one is similar to that question of a remainder. If you check, divided by this
one.
The remainder is -7. So I want you to try this one.
I would try this one, yeah.
And determine the value of P. All right.
Yeah, I'll try this one.
Then this one, factorize completely. We talked about this. So here you have to find the first factor, then you do the long division.
Yeah. I'll try this one as well.
You're gonna try it also. Then this one is the same as the last one.
This one, because they already
that
give
one,
us a factor.
you can also try this one. But yeah, just want to have a clarity before you try it. Check here, it's our cubic expression. We do not have x here, so you can just write this as f of x is equal to x cubed plus 3x squared plus 0x. You put the part that one without x as what? As 0x.
0x, yeah.
Exactly. So already you are given that it's a factor. This one, they already gave you a factor. So you are just gonna simply divide because it's already a factor. But now you're having what? X cubed plus 3x squared plus 0x minus 4. Then you find the other factors.
So that I can prove that the x minus 1 is a factor. I can prove that net just gets 0. Yeah, I have to.
Exactly. You can actually prove to say if they can make a mistake. Then when you are calculating, you are wondering why is it I'm not getting the exact answer. They can make a mistake, so you can actually prove it.
Prove it. Okay.
All right. So I think for this one, we'll see. So what I want you to do is to work more questions.
Let me try.
So I'm still downloading the question papers for science, and so that we can work question papers. But for this one, I think it's enough. We'll see tomorrow. I just want to fix my phone so that I download the question papers so that I'll send them. You try them for science.
For science, okay. I really appreciate it. Let me try to work on those questions.
All right, no problem. After this, you can just send them on WhatsApp so that we can. I'll check them. If there's anything, we'll just work on it.